Okay, so I'm going to show you how to do an ester hydrolysis. So I'm not showing you the exact problem that was in your homework, but it's a very similar problem, and that you are starting with something that is an ester. So if you try to go back and remember what is an ester, anytime you have an ester, what you're going to have is an R group bound to a carbon that is in a carbonyl. So it's double bonded to an oxygen. Then you have it bonded to another oxygen, and then that other oxygen is bound to an R group. So this is the format for all esters. And what you'll see in the homework is you also have an ester. It's just a different ester. So when you look at it, if you just kind of circle the stuff that's R groups, and just label it that way, right? So we'll call this maybe R1 and we'll call this R2. Right, and let's maybe do them different colors, something like that. This is R1, and we'll color it in blue. All this is R1, and then we'll do this in red, R2, and we'll color R2 in red, just so that it's kind of easy to keep track of, right? So this is our red, and then this is our blue. Okay, so what do we want to do? Well, we're going to undergo what's called a hydrolysis reaction. In a hydrolysis reaction, you are going to react something that, for example, is an ester with water. You remember water is HOH. Now, you can't necessarily cut the water molecule in half. It's going to be hydrolysis. So you're going to break water, but you have to break a bond. So we're just going to say right here, we're going to break this bond. And so what's going to end up happening is that you're also going to break this big ester molecule. And you're going to break the ester on one of the sides of the oxygen, just like you did in water. So water, we could have broken it here, or we could have broken it there. It doesn't matter. But on one side or the other of the oxygen. So let me do the same thing on the ester. I'm just going to do it right here. Doesn't matter which one you pick. Now, whichever side of the ester that you gave the oxygen, that side is going to pick up just the hydrogen. So this side of the molecule right here is going to pick up, it's going to bond from the oxygen, just the hydrogen. So I'm going to go ahead and rewrite that. I have a hydrogen that came from right here, and then I'm going to go backtrack. I'm going to go this way. I'm going to follow this, and I'm going to pick up the oxygen. And you don't have to put a line between them. You could just write HO. And then that oxygen is bound to R2, whatever that R2 is. In this case, it's C30H6. Doesn't matter. It's still that same R2 R group, right? So the R group has gotten an oxygen and a hydrogen. So the same thing is going to be true about the other side of the molecule. So here, let's see if I do pink. I'm going to take this hydroxyl and I'm going to attach this to the side of the molecule that didn't get the oxygen. So right there. So I'm going to bond from the oxygen to the carbon. So I'm going to write my R1 group. I'm going to start coming in this direction. I'm going to go C15. I'm going to do H31. Then it goes to the carbonyl carbon. Now that carbonyl carbon is going to be bound, going to go and pick up oxygen. And then that oxygen is bound to a hydrogen. So what you end up with are two new compounds. One of those compounds, if you started with an ester, one of the product compounds is going to be a carboxylic acid. What's a carboxylic acid? A carboxylic acid is some kind of R group attached to a carbon, double bond to an oxygen, and a hydroxyl. And that's exactly what we have right here. This is a carboxylic acid. The other molecule is going to have an alcohol in it. So anything that has an OH and an R group is an alcohol. And so you're going to make a carboxylic acid and an alcohol. All right. If you have any questions, let me know.